Hello everybody, in this question the curve y equals xy plus x square minus 4 intersects a line y equals 3x minus 1 at the points A and B. Find the equation of the perpendicular bisector of the line AB. So to find the points of intersection, so what I can do is I substitute y with 3x minus 1. So I can write 3x minus 1 is equal to x times 3x minus 1 plus x square minus 4. And then I can simplify this. So 3x minus 1 is equal to 3x square minus x plus x square minus 4. So I would get 3x square. If I were to bring them all to the left hand side and simplify, I would get 4x square. So and then minus 3 minus x minus 3x would be minus 4x. So minus 4x, and then minus 4 plus 1 is minus 3, and that equals 0. So then I need to factorize this. So 4 times 3 is 12, and 6 times 2 is 12. So I can say 4x squared minus 6x plus 2x minus 3 is equal to 0. So if I say 2x times 2x minus 3 plus 1 times 2x minus 3 is 0. So I write 2x minus 3 times 2x plus 1 equals 0. So if 2x minus 3 is 0, then x equals 3 over 2. And if 2x plus 1 is 0, then x equals minus 1 over 2. So then we can find the subsequent values of y. So at x equals 3 over 2, let's say at x equals 3 over 2, y equals, so 3 times 3 over 2 minus 1, sorry, bracket is at the wrong place. So 3 over 2 minus 1, that is 9 over 2 minus 1, that is 7 over 2. So we get one point as 7 over 2, 3 over 2. So here I get the points as 3 over 2, 7 over 2, and then I get the other points, which is A, which is B. It doesn't really matter, but then it'd be interesting to see if we could have a sense of what the graph would look like. So if I had lines like a x and y axis, the graph would look somewhat like this. So, and then somewhat like that. So then and the line would pass to somewhere there. So these are the 2 points that are A and B. So on all the negative signs would be B. So that's B and that's A. So I can probably say that this is A. Say is 3 over 2, 7 over 2. And then if I look at the other value of x, x is minus half. So then at x equals minus half, so then y equals 3 times minus half minus 1 minus 3 over 2 minus 1, that is minus 5 over 2. So hence the point B would be minus half minus 5 over 2. So we have the 2 points A and B now. So the next thing to do is we need to now find the equation of the perpendicular bisector of the line. So first we need to find the midpoint of AB and the gradient of AB and the gradient of the perpendicular line. So if I say the midpoint of AB, to change the pen color a bit. So midpoint of AB, so I can write this as 3 over 2 minus 1 over 2 divided by 2 and 7 over 2 minus 5 over 2 divided by 2, and that is equal to, that's half, half. So that's the midpoint, and through this midpoint there's a perpendicular, there's a line passing through the midpoint. So if let's call this perpendicular line as P. So P is the perpendicular line, a perpendicular bisector of AB. So I also need to find the gradient of AB, so I can do this here. So I write the gradient of AB, and that is equal to minus 5 over 2 is y2 minus y1 minus 7 over 2 over minus 1 over 2 minus 3 over 2, and that is equal to 5, 7, 12 over this minus 6 over 4 minus 2, that is equal to 3. Hence the gradient of P, gradient of P, so that would be equal to minus 1 over 3. The product of gradients is to be minus 1. So the gradient of P is minus 1 over 3. And therefore, what we can work out is the equation of the line. So hence the equation of P, that would be y equals minus 1 over 3 x plus c. Okay, so this line would passes through the point, so which passes through the point, the midpoint, half and half, so which passes through so therefore we can write half equals minus 1 over 3 times half plus c. So c equals half plus 1 over 6, that is 6, 4 over 6, that is 2 over 3. So hence the equation of the line of P would be y equals minus 1 over 3x plus 2 over 3. It can also be written as, if we were to multiply throughout by 3, 3y plus x is equal to 2. Or I can say 3y plus x minus 2 is equal to 0. So hence, whichever format you choose, that is the answer.